Okay, so problem 85 is asking a child in danger of drowning in a river is being carried downstream by a current that flows uniformly with a speed of 2 meters per second. The child is 200 meters from the shore and 1,500 meters upstream of the boat dock from which the rescue team sets out. If their boat speed is 8 meters per second with respect to the water, at what angle from the shore should the pilot leave the shore to go directly to the child? So here we have a visual representation of where the child is in relation to the shore and the dock. So we have the child 200 meters out from the shore, and we have the child 100 or 1,500 meters upstream of the dock. And the child will be moving this way towards the dock, and the dock or the boat that is going to get the child has to leave to get the child. So we know two bits of information to find this angle. First, we need the x and the y, in which we have the y is 200 meters and the x is 1,500 meters. So we're able to find this angle by taking the inverse tangent of 200 divided by 1,500 to get that angle is 7.59 degrees. And we have, since we have that angle, we can now use that to multiply by our boat velocity, which is 8 meters per second. So you take the 8 meters per second, multiply that by the cosine of 7.59, and you'll get that our velocity in the x direction is 7.93 meters per second. And then you take the same velocity, the boat velocity, 8 meters per second, multiply it by the sine of this angle that we had found, and you're going to get your y velocity, which is 1.06 meters per second. The only thing that we need to change is our x velocity because we're going against the river. So we know that we need to take our 7.93 and subtract the 2 meters per second that the river is moving. And we get that our new x velocity is 5.93 meters per second. Now that we have our two velocities, our x velocity and our y velocity, we can do the same thing that we did here. And we take the inverse tangent of the of the y divided by the x, and then that gets us that our angle that we need to leave the dock is 10.13 degrees, and with significant digits, 10.1 degrees.